Hi everyone, in this video, I'm going to show you how to balance chemical equations. I'll go over two different type of chemical reactions in this video. Here is the first one. We have methane plus oxygen produces carbon dioxide plus water. Okay, we want to balance this equation. First of all, a balanced equation means the number of atoms for each element on both sides of the reaction should be equal. So if I want to balance this equation, the first thing I need to do is to draw a chart. On the left side of the chart, I write down the elements which we have on the reactant side. So what I have: carbon, I have hydrogen, and I have oxygen on the reactant side. On the right side or product side, we have of the same elements C, H, and O. Okay, we want to make sure we have the same amount of atoms for each element on both sides, right? Okay, so on the left side, how many carbons do I have? I only have one carbon atom on the left side, so I write 1. How many hydrogen do we have? We have 4 hydrogens, so I write 4. And then for oxygen, I have 2 atoms of oxygen, so I write 2 over here. On the right side, product side, we have 1 carbon, we have 2 hydrogen, and how many oxygen do we have? We have 2 atoms plus 1, 3 atoms of oxygen on the right side. Okay, so carbons on the left side are 1, on the right side are 1, so they are balanced for now. Hydrogen, I have 4 hydrogen on the left side, 2 hydrogen on the right side, so I need more hydrogens on the right side. So what can we do here? I can multiply this H2O by 2, so I put a coefficient of 2 over here. This means this whole thing, H2O, should be multiplied by 2. So if I do that, 2 times 2, that's 4 hydrogen. So now on the right side, I have 4 atoms of hydrogen. So it becomes 4. So as you know, by adding this coefficient, it affects oxygen as well. So how many oxygen do I have now? I have 2 atoms of oxygen here and 2 here, 4. So I have 4 atoms of oxygen on the right side. Just remember, you cannot change the subscripts of a compound. I cannot just change these numbers. They should stay the same. The only thing we can do when we're balancing equations, we can adjust the coefficients. We can put coefficients. We cannot touch these subscripts. You have to keep that in mind. Okay. So I have 1 carbon on the left, 1 on the right, 4 hydrogen on the left side, 4 hydrogen on the right side. So oxygen, I have 2 on the left, 4 on the right. So what can we do here? I have to add 2 more on the left side. So I have O2 here. I can multiply this by 2. And now 2 times 2 is 4. So I have 4 atoms of oxygen on the left side as well. So let's check all the elements again. See 1 atoms on the left, 1 on the right. So that's balanced. For hydrogen, I have 4 on the left, 4 on the right. That's balanced. For oxygen, I have 4 on the left, 4 on the right. So that's balanced as well. So this equation now is balanced. All right, let's move on to the second chemical equation. I have this chemical reaction. Cu plus AgNO3 produces CuNO3 plus Ag. Okay, what we do, we need to draw our table, right? Our chart. So on the left side of the chart, I want to write down the elements which we have on the reactant side. So I have Cu, copper. I have Ag, silver. And I have NO3, nitrite. Okay, so there's a tip here for you. Whenever you have polyatomic ions, NO3, you know, NO3 is a polyatomic ions. Whenever you have this type of reaction, which contains a polyatomic ion, which remains unchanged on both sides, if you pay attention here, I have NO3 on the left side and I have NO3 on the right side. It remains unchanged. So I can balance this as one unit. I can write it as NO3. You can write it as N or separately break it down, but it's easier to just write it as one unit and balance it as one unit. So I just gonna go with this NO3. I wanna write it down as one unit and balance it because it remains unchanged on both sides, okay? So on the right side, product side, I have the same elements. I have Cu, I have Ag, and I have NO3. Okay, how many Cu do I have on left side? I have one. How many Ag? I have one. How many NO3? I have one. On the right side, I have one Cu. How many Ag? I have one Ag. How many NO3? I have two atoms of NO3. So 2. Okay. So Cu 1 and 1, so it's good. Ag is good. NO3. We have to deal with this NO3. I have 2 on the right. I have 1 on the left. So we have to make them equal, right? So on the reactant side, I can add a coefficient of 2. That means I can multiply this compound AgNO3 by 2. So if you put a 2 for as a coefficient here, that's going to affect Ag and NO3. So now we have 2 atoms of NO3 on the left side. So this becomes 2. And also it affects Ag as well, right? So I have 2 atoms of Ag. This becomes 2. Okay. Now let's check again. Cu 1 on the left, 1 on the right. So we're good. Ag, I have 2 on the left, 1 on the right, which I have to fix that. Balance that. NO3s are good. I have 2 on the left, 2 on the right. So let's go with Ag. I have 2 on the left, 1 on the right. So on the product side, we need to add Ag. We need more Ag on product side. So here I can just put a coefficient of 2. So multiply this Ag by 2. Now I do have 2 atoms of Ag on right side. So it becomes 2. Okay, let's check again. Cu 1 on the left, 1 on the right. So that's balanced. Ag, I have 2 on the left. On the right side, I have 2 Ag as well. So that's balanced. NO3, I have 2 on the left side and I have 2 on the right side. So that's balanced as well. So now this equation, this chemical equation is balanced.